Good to see you all. When I say good to see you, I don't actually mean that I can see each of you, but like with AIS and Radar, I have electronic evidence that you're there. Now we're seeing more and more discussion, especially in forums, about the relative merits of Radar versus AIS. So I'm going to look at both the systems and the pros and cons in their operation. So we're going to look through from first principles, how they work, the pros and cons, some of the options, perhaps when you're installing them, some basics in terms of usage, and finally we'll talk about what the big ships say and do about AIS versus Radar and their treatment of you. And then finally we'll come in with some Q&A and discussion. So if you've got any questions, please use the button towards the bottom of your screen, and you can put in a question anytime during the presentation, and then Jules will go through them at the end, and I will attempt to answer them. So why do we have AIS or Radar? Well, there's a number of different reasons. Firstly, it's to see what you may not see, maybe because it's too far away, maybe because there's fog or rain, maybe it's obscured by other objects. Those are the basics, but it can also provide you with information you may not otherwise have, and it can also alert others to your presence. So those are the main reasons for having one of those two systems. Now we're going to start off by looking at Radar, which officially stands for radio direction and ranging. Sorry, radio detection and ranging. Although I always think it's actually more useful to talk about radio direction and ranging. I'm sure we all know the basics of radar. They have a rotating aerial, sends out a radar pulse all the way through 360 degrees. Objects reflect it back, and your receiver can determine the relative angle to you, the distance away, and the strength. And of course, that information is then painted, is the word normally used, onto your radar screen or maybe overlaid onto your plotter. Now, it's useful to know that there are two types of radar that are typically used in marine. There's the S-band and the X-band. Smaller boats tend to use the X-band because the actual radar antenna can be smaller and it gives you slightly better definition. But big boats, ships in other words, typically use the S-band primarily because it's less affected by weather. So it's an important thing to be aware of, and we'll come into why in a second. The other thing is, let's talk about analog versus digital radar. Well, really, the radar itself is always a sort of analog system, but the way in which the received signal, those blobs, is actually processed is better being digital because it will give you lots of extra information, which we'll talk about in a moment. Now, radar reflectors are something which help you be seen by big ships. They reflect a bit more back than your basic boat would be. So a radar reflector enhances that reflection. Now you can have lots of discussions about which design or brand is best, but the important thing to notice is that it's one of the few things for British boats, for small vessels, that is actually required by SOLAS, the Safety at Sea legislation. And the other thing to be aware of is the position and orientation can be critical, in particular what's called the catch rain one, the metal plated radar reflector you can see there. It's very important that that is put at the right angle. Now you can also have a radar transponder, which is a powered device. So it takes power from usually your 12-volt system. It will detect a radar pulse coming from a ship and then transmit back a bigger than usual pulse. So it enhances the echo from your boat, makes it more clear that you are there, makes your presence more obvious. Some of them may also alert you to the fact that you've just received a pulse. So this is something particularly useful in far out at sea, because it uses very little power, and at most of the time there'll be no ships about. But if you have that on and it gives a little bleep to say, I've just received a pulse, then somewhere within radar range is a big ship. Now you can get these in single or dual band products. Now I would say it's important to have one that is dual band. But there's one potential problem with these, and that is that they may not be triggered by the newer things which are called broadband radar. Now, the radar suppliers are always trying to improve their products in various ways. And over the last few years, we've seen 3 new bits of technology come out. There is broadband radar. We don't really need to know that it's frequency modulated continuous wave. But the effects of using broadband radar is that it reduces the power consumption. It gives you a better resolution, but slightly less range. But the 2 disadvantages are it may not trigger some transponders, the devices we were talking about on the previous slide, and it may not trigger raycons. Now, raycons, the devices that you get perhaps on lighthouses, bigger buoys and so on, which, like a transponder, pick up your signal and reflect it back in a particular, usually a Morse code signal. But those are actually becoming less and less common and being replaced by AIS, which again we'll talk about later on. The second type of technology that's come out has been pulse compression, which has the same benefits of reducing power and giving better resolution. And then the third is Doppler, and you can mix these technologies. So Doppler gives you an immediate indication of a target's relative course over ground compared to you. So if we look at the image on the right, the green blobs are objects which are moving away from you, and the red blobs are objects that are coming towards you. So it gives you an immediate indication of which is which. Now, be aware that when you are perhaps selecting radar, the choice that you have may be limited by the plotter supplier. So it might well be you would like a particular type of technology, but you then find to be compatible with the plotter you have at the moment, you can't adopt that. And I'll just mention at this point as well, most of my images are from Raymarine instruments, not because I favour Raymarine above anybody else, but getting copyright approval from Raymarine is much easier than the other manufacturers. So radar, pros and cons. Well, first of all, it's capable of seeing everything. You can see ships, you can see small boats, you can even see buoys, lobster pots. I've seen lobster pots. We were in some very thick fog off the north coast of Spain, and I was trying to work out what these particular blobs were on the screen. And as we approached them, we discovered they were lobster pots. You can see the coast and you can see rain. But the big thing that makes radar much more powerful in some ways than AIS is that you're entirely self-sufficient. You are not depending on somebody else doing something so that you can see them. But the disadvantages of radar is that it can be difficult to adjust. It can be difficult to interpret what those blobs actually mean. And you know something is there, perhaps because there's a blob there, but what is it? It can be affected by rain. So sort of the opposite of seeing where a rain cloud is that the effect can be that rain conceals something, as can a rough sea. And then lastly, there is the effects that you get on a small boat. If you're heeling a lot, for example, then it may well be that objects to the side cannot be seen. Most radars have a typical angle of view of about 20 degrees. And similarly, if your boat is pitching up and down, then again, it may miss particular objects if at that particular moment you're pointing upwards more than 20 degrees. So what about the options on radar? Well, most small boat radar now is actually digital. So the things you've got to look at are things like the size, the weight, the power consumption, the cabling, that sort of information about how you're going to fit it and what its effects are going to be. Now, there's a number of choices of where you put the scanner. I think most people tend to put it sort of 2/3 of the way up the mast, but it's often easier to mount it, as you see on the picture on the right, on a post at the stern of the boat. But the bigger and higher it is, then the better. And consider the beam width. One other thing that you increasingly get now are radar devices that will swing with the boat. So when you're heeling, the radar is still pretty well horizontal. Think about connectivity. How are you going to connect it to your other instruments? And is it going to be a separate unit or integrated into your plotter? But then there's a whole other set of decisions as well to look at, about the control features, the adjustments and the presets maybe. MARPA, which we'll come on into in a second, things like time to transmit if power is an issue. Things like the alarms and whether you want colour, whether you feel that colour is adding something to the information being presented to you. So a very basic diagram here. You have a radar scanner mounted somewhere. You have some cabling from it to your radar controller. That cabling might be the power and the data. So you then end up with either two thickish cables or one much thicker cable. But increasingly now, data may be coming down from Wi-Fi, in which case the only cable you need going to the radar scanner is for power. So the radar scanner is connected to the radar controller, and then from the controller, that information is then either sent to a dedicated radar display, or it might be sent, and in fact probably more commonly now, sent to your plotter display. And again, that information might come in a wired form, or it might come across on Wi-Fi. So setup and use. Well, the first thing, and I'm aware people often overlook this, is to have radar, you must have an Ofcom license. You must add it to your license for your boat with Ofcom to say you now have radar because you are transmitting something. Second thing you must do, obviously after you've fitted it and run all the cables through, is make sure the alignment is correct. So make sure that when it thinks it's looking directly ahead, it actually is. Think about the power modes that are used. If you have plenty of power on board, then you don't need to worry about the standby and timed. But basically off means it's using very, very little power. Standby means that it is ready to go once you hit the power button and the scanner actually starts to transmit and receive. Timed means perhaps that it will give a couple of sweeps every 10 minutes, for example, as a way of saving power, but still looking out for any ships. And then on when it's actually transmitting that radar signal and therefore getting back information that you can use. Now, you've also considered the orientation of which way round the radar information is presented to you. I have to say my personal favourite is north up. So that means that I'm looking at the radar in the same way that I would be looking at my plotter screen. But equally, you could do course up, which is a very good way of looking at it, because then from a sort of logical point of view, in front or going upwards on the screen towards the top is as if going directly in front of your boat is heading. Head up is probably the least useful, particularly on a small boat, because with head up, the boat turning slightly will mean that the radar image is constantly rotating a little bit one way and then a little bit the other way. So my suggestion would be north or course up. Consider the view method, whether you want it as a separate radar screen or whether you want it overlaid perhaps on your plotter. Again, personally, I prefer it overlaid because it gives me a little bit of a sense of the scale that I'm looking at, and I can also then compare it with objects that are on the chart. So for example, if I see some land and I see a reflection of that, I know everything is working well because everything fits in the same scale. But also, if you're way out to sea, there's not going to be any land to look at, in which case separate is probably better because there's nothing there to distract you. So the next thing to do is to get used to the controls and what is shown. And of course, one option of doing that is to actually do an RYA radar course, which I think lasts a day. But the things to particularly focus on what presets your particular radar has. It may have a preset for harbour, maybe for coastal, or maybe to open sea. And that will tweak things like the gain, the rain, the sea clutter, the things we'll talk about next. It will also change the alarm settings potentially. So look at the other controls, the gain, that is how small an object, it will make sure that it sees a reflection coming back from it. The rain, you may want to filter out the rain so that it is not confusing the image on the screen. Or it might be that you actually want to see the rain, perhaps because you're trying to avoid a squall. And then sea clutter, generally it's the wave action around you. I've tended to find actually with most fogs that I've been in, it's been fairly calm and therefore there isn't much sea clutter. There may well be other settings, and there's MARPA, depending on the model, which we'll look at in a moment. And the thing is, all of these need a little bit of adjustment for different environments and conditions, and maybe even what you're doing. When I'm using radar, quite often I will be changing the gain and changing the range that it's set to from minute to minute, so that I have a quick look over a large area, and then I will look more closely close up. So in use, as we've said, you adjust it to suit the locale and the conditions that you're in. Having done that, you're then looking to spot targets. So you may spot something on the screen, and then the next question is, well, is this a risk to me? Is it moving or not? It might appear to be moving on the radar, but of course that might be some stationary object like a buoy, in which case it's not moving, but because you're moving towards it, it appears to be moving on the radar. How far away is it? If it's a long way away, maybe you don't need to worry. How fast is it moving and in which direction? Well, it might be a long, long way away, but on the other hand, if it's moving very fast, then it could be a risk to you sooner than you might otherwise expect. So you're looking at things like, as we see on the image on the right-hand side, the blobs that we see there, the range, the rings there will be showing us the range. And usually on plotters and on radar screens, you can move a cursor and position it somewhere onto a blob, and it will tell you how far away that particular object is. You can also use what's called an electronic bearing line. So you can move a line around the circle of where you are on the screen, position it such that it's crossing a particular blob, and it will then tell you the direction, the electronic bearing to that particular object. And of course, like if you're in the cockpit using a hand-bearing compass, if that electronic bearing line going over the object is not changing, then of course there is a risk of a collision, because it means it is coming towards you. Or I suppose it might be going away from you if it's getting further away. But let's talk about MARPA. So MARPA. MARPA stands for Mini Automatic Radar Plotting Aid. Now, big ships have ARPA, which is Automatic Radar Plotting Aid. We have Mini ARPA. And the main difference between the two is the level of sophistication that's provided, and ARPA in particular, as I understand it, I've never used ARPA myself, will automatically pick on particular objects on the screen, whereas in MARPA, you have to do that yourself. So let's talk about MARPA. First of all, the process will depend on the model of radar system that you have. But generally, what you do is you put the cursor on a particular target, so a blob that's on there. You would then press a button to say, I want this to become a MARPA target or object. And then you watch and wait. Over a few scans, as your radar goes round, it will start to average the returns that it's getting and start doing some calculations. And it will give things like the course of that object, it will give it the speed, but it in particular will give you the CPA, the closest point of approach. And it will also give you the time of closest point of approach. So you now know that something is, let's say, going to pass within a quarter mile of you, and it's going to do that in 10 minutes' time. You've then got to consider whether you need to take any action. So what it's done is very quickly and very effectively giving you that critical information about whether you need to do something or not. MARPA can generally track multiple objects. So you might have 2 or 3 objects that you've picked on the screen, and the radar will then provide you with that information, the CPA and the TCPA, for each of those objects. Now, one thing to be aware of, the interpretations, the calculations that the radar has to do to achieve that are relative to you. So if your helmsman is moving the boat about a bit, or if the waves are swinging the boat about a bit, then those calculations suddenly start to become a lot more complicated, because the blob appears to the radar to be moving about in unpredictable ways. So your heading, your course over ground, your speed over ground can make big changes. Some MARPAs will cope with that better than others, and it's worthwhile perhaps looking on the internet to see if there's any particular reports about how good the MARPA is on one device rather than another. A few years ago, this used to be a major problem. I'm not sure it is by any means now. So the other thing with radar is alarms. You can usually set alarms on your radar that will give you a warning signal if it sees any reflection. But of course, the risk with that is that it might give you a reflection or an alarm on something that actually isn't there. Because one of the problems with radar sometimes is it picks something up just because it's a reflection of a big wave or something like that. So it might give you an alarm on any reflection. It might give it an alarm on a proximity, i.e. something within a mile, or maybe within the shape. So you can say, I want the alarm to go off with anything that's a mile in front of me, but astern of me, I'm only worried about half a mile. You could also set the alarm on a MARPA target. So you can say, okay, I want an alarm on a MARPA target if its CPA is going to be less than half a mile. Or also on target loss, because occasionally MARPA will lose track of an object. And again, it can give you an alarm to warn you of that, and you can then re-grab it. So what else can you use radar for? Well, you can use it for navigation because you can see buoys, you can see land. It's not perfect because the width of the beam will blur the response and can, for example, in this picture we see on the right-hand side, if we looked at the radar image on the right, there doesn't appear to be an entrance. But if we look at the chart on the left, we can see there is an entrance there. What's interesting as well on this one is that all of the buoys are being shown up as red objects. Even the posts going out to the fort, because this is at the eastern end of the Solent, even those are showing up on the radar. So the key thing about radar is that the data, the firm data that it has to work from is the image. On that image, you've got the range rings, you might have an underlying plot, you've got size and density and shape. Need to pay attention which way round it is. You have got a risk of multiple reflections sometimes, particularly if you've got a number of large ships. And of course, then you've got the digital features that are all still based on that image information. So MARPA giving you the radar plotting aid, the color perhaps in terms of the reds and greens as to which way an object is moving. And also you can actually have the track of an object being shown on the radar. So radar is a very good tool which is self-sufficient for you to work from. And of course, radar's been around for a long, long time. Whereas AIS, Automatic Identification System, has not been around anything like as long. The AIS really started around 2002, which is when the International Maritime Organization mandated that all ships over 300 tons and certain sizes of passenger ships were required to fit and transmit an AIS signal and to monitor it. And this is called AIS Class A. Some nations actually require AIS on smaller ships. The signal that AIS sends out is on a VHF channel, so it has a very similar range to the VHF that we normally use for ship-to-ship and ship-to-shore communication. And the data that Class A AIS sends out includes the ship's identity, so its name, its call sign, MMSI, type of ship, position, course, speed, navigational status, various things that are probably not particularly useful to us, although ROT, rate of turn, is something that can be quite useful because you can actually see whether a ship is currently manoeuvring. And we'll talk about that a bit later on. So that's Class A. So any ship, having said that, can then have an AIS receiver to pick up those AIS messages on its AIS receiver through VHF. And the actual costs of AIS receivers have come down astonishingly in the last few years. You can even get some units under £100, although you may need to check whether or not they're officially approved for use. Typically on a small boat display, you might get a list of the data, or you might get it displayed on a plotter, and we'll look at that a bit later on. So the point is that you've got this information coming into you about these ships, which you know by name, you know their left and long, you know their course, you know their speed. So from that, you can determine which ships could be a risk to you and decide whether you need to do something about that. So we then come on to Class B. So any ship can add an AIS transceiver to both receive, as we've been talking about on the previous slide, but also to transmit AIS. Typically AIS Class B, but there's nothing to stop a small boat having Class A as well, or instead of Class B. Class B sends less data. So Class B sends the ship's identity, the same things, the name, the call sign, and the MMSI number. The type, so it might say sailing vessel, for example. The position, the lat and long that is. The course over ground, and the speed. So if you're sending that information out and you have both a receiver and a transceiver, it means that you should be aware of other ships by using your receiver, providing those ships have AIS, and they should be aware of you if you are transmitting. Now, AIS is becoming more and more common on lots of other objects. So, for example, buoys, pierheads, lighthouses. I mentioned earlier that raycons seem to be going out of fashion and being replaced by AIS. So those objects are called synthetic objects. So they are an AIS signal coming from something which is not a ship, and actually the transmission may not even actually be from that particular object. And if we look at the diagram on the right, that's the entrance to Bembridge Harbour on the Isle of Wight. And those little pink circles are the marker buoys going into the channel into Bembridge. Now, if anybody of you have been into Bembridge, you will know those buoys are quite small. So there's no way they are transmitting that AIS information from that actual buoy, but it doesn't matter. Somewhere, presumably close by, there is a transmitter sending out information on behalf of each of those buoys, with each of those buoys' latitude and longitude. You can also have unmarked objects. So, for example, rocks under the surface. These are called virtual objects. Again, obviously, they're being transmitted from some other object. You can have man overboard, so you can actually carry an AIS transmitter in your pocket so that when you go overboard, it will transmit that signal and not say, I'm a sailing vessel or I'm a passenger liner, but I am a man overboard. But be aware, not all systems will actually receive or show these. If you have an AIS receiver, which is quite old, it may not understand the particular signals for these devices. Similarly, if you have a plotter, which is quite old, it may not show those. So, for example, my AIS receiver will pick up man overboard, buoys, etc., but my plotter will not show them. So if I want to see them, I've got to look on another dedicated device. So lastly, in terms of sort of the transmission, I want to talk about satellite AIS. Now, I mentioned that AIS goes out on VHF, and VHF has, by its nature, a limited range, typically to the horizon. Satellite AIS is actually still picking up those same VHF AIS signals, but from a huge area. So these are low orbit satellites that are picking up AIS signals. And as we can see from the marine traffic image on the right-hand side, it's actually picking up ships right out in the middle of the Atlantic because they are sufficiently low that they are within the range of the VHF. But be aware that that information is usually somewhat out of date. Typically about 90 minutes, or typically on average, about 90 minutes out of date. So it's useful to a shipping company worrying about a ship coming from, let's say, Japan to London to know roughly where it is, but it's not the sort of thing that could be used for collision avoidance or anything like that. It's more useful, and therefore it's a paid for service for shipping companies. But it's useful to know that that information is there and can be picked up by satellites. And if you wanted to, you could take out a subscription to receive it. So let's look at a bit more about how it all works. The AIS transmitter gathers its ship's data, so the static data, like the ship's identity, The passage data, like where it's going to, what its status is, whether it's anchored, fishing, whatever. And the changing data, like the position, the speed, course over ground, rate of turn. It then checks to see if anything else is transmitting, and if so, it waits, and then it will transmit some or all of its data. Note here that Class A transmitters have a higher priority than Class B for transmitting. So Class A transmits the changing information, which is the speed over ground, course over ground, position, etc., between every 2 and 10 seconds. But it only does it every 3 minutes if it's an anchor. And it sends the full data, which includes the name of the vessel, for example, every 6 minutes, and it transmits it at 12 watts. Class B transmits that same changing information every 30 seconds, so much less frequently. And if you're going under 2 knots, it only transmits it every 3 minutes. It sends the full data also every 6 minutes, but it only transmits at 2 watts. There is a sort of halfway house now available, which is Class B+, which transmits at a slightly higher power and a slightly greater frequency, or regularity, perhaps I should say, than frequency. Now, one of the things people say about AIS is that it's always out of date because it's only transmitting something that was the case a little while ago. But if we look at Class B, if somebody's doing 20 knots, let's say there's a motorboat doing 20 knots, the worst case position is it's going to be a 1/6 of a mile out. With Class A, if the ship was doing 20 knots, then the worst case inaccuracy is about a 20th of a mile. So really the inaccuracies are not that important. So the pros and cons of AIS, well, it's easy to fit. It's easy to get definitive data because you've got real strong information. It's digital information rather than a blob on a satellite, and it's easier to interpret. But of course, not all boats transmit. Many other objects are invisible, and it's dependent upon what others transmit and watch. So for example, you get questions like, do some send the wrong data? Do some not watch Class B? And I believe even there's new devices for small boats where you can say, I don't want to know about Class B transmissions. And do some not transmit at all? I think one of the things that can be quite common is fishing boats will turn off transmission so that the fishing boats they're competing with don't know where they are. The same might apply to yachts that are racing. They don't want their competitors to know where they are. So options, AIS, well, obviously you can have a receiver or you can have a transceiver. And when you do have a transceiver, you don't have to transmit all the time. You can turn transmission off. Do you have it as a separate device or do you have it integrated either into your VHF device or into your plotter? Do you have a separate VHF aerial for it or an aerial splitter? Some people say aerial splitters are not particularly good, but if you get a good aerial splitter, it will not have the sorts of weaknesses that a cheaper one will have. Where do you put the aerial? Many people say it's quite sufficient to have it low down, perhaps on the push pit, because the things that they're particularly looking out for are big ships. The big ships will have the aerial high up, so you can still see a long, long way. But if you're looking for other smaller objects, like another yacht that's also got the aerial on the push pit, then maybe you won't see them so close, so far away. Then connectivity, how do you connect it to the rest of the devices on your boat? And then we'll look at the display and the control methods and features. So, quick diagram, aerial splitter or not, VHF shared aerial or dedicated aerial. You have to have a dedicated GPS aerial for an AIS unit. That is one of the mandatory features of AIS. You might have an external transmit switch for the reasons I just mentioned, so you can turn off transmission. And then, like with radar, do you have a dedicated display for AIS or do you just share it onto your plotter screen? In terms of AIS setup, well, again, if you are transmitting, you need to add it to your VHF license for your boat. You've then got the wiring and then the setup of the vessel's identity, the type. Now here is a very common fault. People fit their AIS system and they accept the default that is offered to them when they're installing it of being declared a pleasure boat, a pleasure vessel. If you're a sailing vessel, please make sure to change that to sailing vessel. Your vessel dimensions, not really so useful on a small yacht, but of course for big ships it is important that they define how large they are. Then you set up your connection methods to the other devices. Note that some AIS systems that you buy will need to be set up by a professional, so usually the dealer that has sold it or is installing it for you. And in some countries this is mandated, but of course in the UK we don't have that legal requirement, so it's up to us according to what we buy. Again, AIS has alarms, very much like radar in terms of proximity or a CPA. And the variations on that will often depend on the mode that you switched it to. So harbour, coastal or open sea. Open sea, it will be a lot further off. So let's just have a quick look at an AIS display. This is actually my mobile phone. My AIS unit sends out information on Wi-Fi and my mobile phone can control everything on it. So here we have a diagram showing me in the center and a boat coming down from the northwest with an MMSI number. We can see the range rings. We can see that it's a north up display. And in this particular case, we can see the MMSI numbers and the course over ground, although not in terms of numbers, just the general direction. So I can see this particular boat is perhaps going to be coming quite close to me. What we can also do, and again, this is just an example of what's on my phone, but you can do it on other devices as well, is call up more information. So here we have a boat actually now past us. It's called Rosalind of Arran. We can see its bearing to us. We can see its range. We can see how long ago we received that transmission, which is 17 seconds ago, and all the other critical information about it. The CPA and the TCPA would appear in that circular box towards the end, just under the ROS of Rosalind, if the boat was coming towards us. Because it's moving away, it doesn't bother to tell us. We might also see it, again, still on my mobile phone here, as a priority list. So the software has determined the risk according to the way that it looks at things, and is now giving us the CPA and the TCPA within that circle. And of course, it's giving us the other information. It's not giving us the name of the ship because in this particular example, they haven't yet transmitted it. I've just turned on my device and we have to wait perhaps up to 6 minutes before we receive that information. So AIS on the plotter, we get much the same information. We can see here in Portsmouth Harbour, if I move the cursor here, you can see there is a ship there and we can see his true course, his speed over ground, the distance, the CPA, the critical path, CPA of about 1.3 miles in 42 minutes. I'm going to have to speed up because I'm running out of time now, so let's go. So we could also on the plotter, and here we see the same boat again, Rosalind of Arran, and we can see the position, we can see the MMSI number, we can see the call sign, the length, and so on and so on. So we can display this information in lots of different ways. So let's have a quick comparison of radar and AIS. So radar is capable of seeing everything. It's weather or sea dependent, but it can also be weather and sea sensing. So if you want to see those squalls, radar can help you. Can be a little bit difficult to use and interpret, which is why you need to practice with it. You can get false echoes, but you can usually interpret them very quickly. And it's a little bit more costly to install and in terms of the power that it uses. AIS only sees other people that are transmitting AIS. Weather is neither seen nor has an effect. It is, I believe, at least easier to use and interpret. The data received is precise, but of course it could be delayed and it could be wrong. And lastly, it's more economical. Now, of course, you could have either, you could have both, you could have neither. I'm not going to make any firm recommendations on that. But let's move swiftly on and talk a little bit about collision avoidance. So most ships will plan to miss a yacht by a mile, and you'll see why I say that in a moment. They will tend to do it very early, and that's actually where the rate of turn on AIS can be useful, because you can look at a ship some distance off and you might see the rate of turn suddenly pop up to a number and then drop down again. It means he has done some adjustment, perhaps to miss you. But of course, your speed and your course varies, so that makes quite a challenge for them. If it's less than a mile, then they may want to do something about it. Challenge sometimes is whether that ship is going to pass ahead of you or behind you. Some displays make it easy to indicate what that's going to be, but of course the other thing you can always do is watch the bearing change, maybe on the AIS, maybe on the radar, or popping up to the cockpit and using a hand bearing compass. So let's suppose that you have determined there is a risk. Then of course the normal collision regulation procedures apply. Which is the stand-on vessel? Is it them or you? What action do you take? The advantage with AIS and radar is, first of all, you probably got earlier notice of there being a risk. So you've got a bit more time to think about what your options are. You should have more certain data to work from. I always find using a hand-bearing compass quite difficult because you're constantly having to remember maybe 2 or 3 numbers if you're coming across a number of ships. Also with AIS and radar, you can rapidly see the results of a change of course by you. And of course, ultimately with AIS, you can more easily make a VHF call to that ship because you know the MMSI number, you know the ship's name. Now, many people will say you shouldn't do that, but on the rare occasions when I've called up a ship, they've been quite happy to chat and say what they're going to do about it and maybe discuss the weather or whatever. So a little bit more on collision avoidance. I want to play some numbers for you. Let's suppose you identify a ship doing 20 knots as a threat, and it's 6 miles away, and you're doing 6 knots. So at the moment, it looks like you're going to be in the same piece of sea at the same time. If you turn 10 degrees to starboard, your CPA with that ship only changes by about 1/4 of a mile, and some ships are nearly that long. If the ship turns 10 degrees to starboard, the CPA changes by about 1 mile. So that just shows how a ship's change can have a much greater effect. If you turn 20 degrees to starboard, your CPA changes 1/2 a mile. If that ship changes 20 degrees to starboard, you've then got a CPA of 2 miles. So ships can and do turn quite rapidly, and that usually they will do it a long way in advance. We often think that we're more maneuverable than a big ship, but at the speed they're doing, they can actually make a much bigger difference in CPA than we can. So is AIS used by big ships? Well, this is a quote from the SAILAS information. The potential of AIS as an anti-collision device is recognised, and AIS may be recommended as such a device in due time. So AIS is not something that the International Maritime Organization yet recognise for collision avoidance. Or it then goes on, talks about, nevertheless, AIS information may be used to assist in collision avoidance decision making, and then continues through. But what do the actual ships do? Well, there was let me just go back a little bit, sorry. There was a discussion on a forum asking commercial seamen what they do in terms of AIS and collision avoidance against small ships. And some of these are very educational. So the first one, AIS is a tool, just like radar and ARPA. They have their place, but none of them take the place of your eyes. That's a very important lesson. Just having your vessel's name via the AIS is a big help. So big ship saying he knows your name because you're transmitting AIS is a big help because he can hail you by name. It's interesting, he then says, this assumes a radio watch is maintained. I think sometimes us in small boats think big ships don't always maintain a radio watch. They have the same view about us. AIS is best for detection of small targets, particularly during times of less than ideal radar conditions. Avoidance is done or supposed to be done using ARPA, as it's more reliable than the AIS for avoidance. So there's a strict interpretation of the International Maritime Organization rules. A minimum 1 mile CPA is very common. A closer CPA triggers a call to the captain. And if you cross the channel frequently, as we've done, you often will see ships making sure they are at least a mile from you. A sailing vessel without AIS may be difficult to detect in rain showers. Mates often do not have the radar tuned properly. I've encountered a discussion with a ship where I pointed out where I was, and he then said, oh yes, now I've adjusted the radar, I can see you. ARPA is the only IMO approved collision avoidance system we have on board. This is from both a practical and a legal sense. And then, to my mind, AIS is far superior to ARPA for both avoidance and sheer information. So AIS is not mandated for commercial seamen to use, but they understand the value of it. So, some conclusions, and I'm very aware we're getting close to the end here. So AIS are different, but aim to solve a very similar problem. Ultimately, you could choose both. You might choose one, you might choose none. Increasingly, those ships, including the future autonomous ships, will expect you to have something. And a few recommendations. First of all, as I mentioned earlier, if you're fitting AIS, please make sure that you've set the type correctly. If you have a sailing vessel, then make sure it is set to sailing vessel, not pleasure craft. With both systems, but particularly with radar, practice in clear visibility and different conditions. And if you've got separate radar and plotter displays, remember their orientation and their scale may be different. It's one of the reasons I like to actually usually overlay the radar on the plotter, because I then know the two scales are the same and I can relate the radar distances to what I see on the plotter, maybe with land or buoys or whatever. And lastly, remember to look out too. Sailing, looking below on your radar and your AIS. Sailing is not a computer game. Everybody remember Space Invaders? So there we are. That's the end of my presentation. I hope that's been useful to you.